Hello, AP Psych. Welcome to your lecture all about sensation. When I say sensation, I am referring to your five senses, smell, sight, and so on, and a few more actually. But this lecture will talk about them, the concept of sensation generally speaking, and then the next few lectures will look at each of those senses individually. Let's get to it. Here are our learning targets. It's not too bad. This shouldn't be too long of a lecture, but we'll find out. Okay. First of all, if I'm going to teach you about sensation, I pretty much have to teach you about perception. Sensation and perception go together, but they are so important that each are going to get its own lecture. Sensation right now, perception in Unit 2. But I do need to introduce them as partners because it's kind of how it works. So sensation is our body's detection and relay of external stimuli and converting it into neural signals. That sounds fancy and academic. Don't worry, I'll put it into like logical, normal words. It's based on external energy and chemicals, things like light, sound, odors, and so on. And it will occur in our sensory organs, our eyes, our ears, our tongues, our skin, and so on. So we have certain organs, certain spots in our body where sensation is received from the outside world. Then our perception is the selecting, organizing, and interpreting of our sensation signals to have meaning. So our brain's ability to choose and kind of sort through all of the sensations that we're getting all day, every day, and make us care about them or think about them. This is based on individual experiences, usually, not usually, always influenced by context in which you smell grandma's cookies. Do you smell grandma's cookies because your mom is making them? Or are you smelling grandma's cookies because your grandma's over and she's making them? So that will impact how you feel about that smell. And the perception piece only occurs in our thoughts. So sensation occurs and then something called transduction happens. That will be our next slide, where that sensation from the outside world will turn into something in our minds, in our thoughts, to have meaning. Transduction helps us do that. So let's define transduction. Transduction is the sensory process that converts environmental energy or chemicals, such as light or sound waves, into the brain. Oops, there we go. First, our sensory organs will receive a stimuli. So like our eyes, our ears, and so on will receive a stimuli, like perhaps like, oh, I see a butterfly. My eye sees a butterfly. That is the stimuli. If the image of the butterfly is strong enough to reach a threshold, like it's not out in the distance where I can barely see it, like I can very clearly see that there is a butterfly, it will reach a threshold and my optic nerve in my eye will go pew, pew, pew and send a message into my brain. So it will go from just an image in the universe, from the external world, and transduce into a brain message, a neural message. Then my optic nerve, a sensory or afferent neuron, will transmit a message to the thalamus, our sensory switchboard, which then will send the signal to the appropriate cortexes of the brain. The cornerstone of transduction are the sensory neurons going pew, 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 sending messages into our spine and up to our brain. So in sum, we see a stimuli like a butterfly, and in the form of light, it enters our organ, our eyeball, and transduces into an afferent neuron, what we're going to call our optic nerve, until it finally lands in the brain, where we don't just see light waves. Our brain actually says, that's a butterfly. So I give this example in terms of sight, but we are actually going to learn how this works in all five senses, plus two bonus senses that you might not even realize that you have. Okay, I keep referring to this word threshold, and we had this word in our neuron lecture as well. Threshold is basically a quantity of a signal that is strong enough to make us notice it. Or in the case of our neurons, our sensory neurons, it is strong enough to make our neuron fire and be like, pew, pew, you see something, pew, pew, you smell something. Okay, so how much of that something needs to be there for our neurons to actually notice it? And we call that an absolute threshold. the minimum level of stimulation, of sight, of smell, of sound, things like that, needed to detect a stimulus at least 50% of the time. So this is an idea, or this is a term for when you first notice something. For example, with sight, the human eye is capable of seeing a candle flame 30 miles away on a clear night. No fog, no rain, no nothing. That setting 30 miles away, nothing interfering with our vision, you would be able to detect a light flickering at least 50% of the time you're tested, um, and that would be considered your absolute threshold. And we could hear a watch ticking 50 feet, 20 feet away. We could perhaps feel a bee's wing falling a distance of 1 centimeter onto our cheek, and so on. So the human body is capable of certain absolute thresholds for when we can even detect a sight, a sound, and so on. We also have thresholds for noticing a difference. When does it get hotter? When does it get colder? When do the lights dim or brighten? Because these things happen in all of our environmental surroundings all the time, but we don't always notice them. So the concept of a just noticeable difference threshold, sometimes known as the JND, is defined as the minimum difference between two stimuli needed for detection 50% of the time. So how much do we need to change the temperature on your thermostat? How much do we need to change the volume on your headphones before you could tell that a change happened? This just noticeable difference has been connected to something called Weber's law. Weber's law says our ability to notice a difference in a stimuli is proportional to the intensity of the stimulus. Okay, this is going to get very complicated for a moment. If you'd like to pause and just listen, this would be a good thing to do. We'll make sure we go over this in class with examples. But let's say, for example, my light. I have a light on my ceiling right now. Let's say it's pretty bright. It's kind of getting a little bit darker behind me. That light being pretty bright would have to change roughly 80%, not 80%, 8%, would have to get 8% dimmer or brighter for me to even notice that it did that. If it was just 3%, 2%, I might not detect it. What we know is that if a stimulus is very high, let's say your stereo is super, super loud, that just noticeable difference will be large. So it takes a bigger change to notice a difference. So if you're at a really loud concert and they tweak the sound just a little bit, you might not notice. It's going to take a major turn up or turn down for you to notice that that concert music volume has changed. If the stimulus is really low, that just noticeable difference will be small. So if I have perhaps like if my lights are all off and I have a flashlight on, and it's maybe faint, a little bit of a dim on that faint flashlight, I'll probably notice right away. Okay, make sure you write down these definitions. I promise we will go over this in class so it makes a little bit more sense than perhaps the words on the page do. Sometimes our senses interact with one another with some interesting results. So sensory interactions are when one sense affects another sense. So let's think of the flavor of a strawberry. When you have a large, juicy, bright red strawberry, you know what it's going to taste like or what the flavor of strawberry will be. Even if we have strawberry lotion or we have strawberry ice cream, we know what that should be. But that flavor is impacted by the actual taste of the strawberry, the smell of the strawberry, the soma or the texture and temperature of that strawberry, and what it looks like. If you think of a strawberry that might be a little bit moldy or might be a little bit tiny, or maybe it's not quite ripe yet, that affects the flavor of that strawberry. So even if, let's say, it looks okay, if it's not ripe, the taste might feel off, and then the flavor of that strawberry might not be good. Another way to think about sensory interactions is think about the last time you had a cold and your nose is all stuffed up. You might not be as excited to eat something, or you might desire spicy food. You either need really strong flavors, or your food might not have as strong of a flavor at all, or a detectable flavor at all, because you can't smell it if you have a cold and it's all stuffed up. At the same rate, if you try to take medicine that you don't like, or drink or eat something you don't like, you might hold your nose or not not look at it, because as long as you can't smell it or see it, it might not have as bad of a flavor. So sometimes our senses interact each other for in good and potentially in bad ways. One of the reasons our senses interact is we actually go through parallel processing. That means that our senses are capable of processing several aspects of a stimulus simultaneously. So for vision, at the exact same time, if we look at a bird, we are going to process the color, the depth or size of that bird, the form of the bird, the movement of the bird, all at the same time. That helps us construct our perception of the bird by blending all of those experiences all at once. So we can tell, is that bird close to us? Is it a threat? Is it flying fast? Is it slow? So while we might see the bird, it's not like a snapshot. It's not frozen in time. And this is, I'm just using the example of sight, but our brain is capable of processing all characteristics of all of our senses all at the same time. So I might be describing something item by item, but our brain is constantly firing. Our senses are constantly detecting multiple features of any given stimuli all at the same time. Parallel processing. Sensory adaptation is kind of a cool concept, and it's basically the idea of what happens when our senses get used to something. So have you ever walked into a room and it either smells really good or really bad, and then after a while you just kind of don't notice it anymore? That's because of sensory adaptation. This is when our sensory neurons, our afferent neurons, develop diminished sensitivity, reduced sensitivity due to constant stimulation. In other words, those sensory neurons will fire messages less frequently because it just they don't need to keep firing. I'll give you another example in a moment. It allows us to focus on information that is changing so we don't need to constantly react to something that is staying the same. So for example, let's say you're wearing a Band-Aid, or like for me, it's my wedding ring is a really good example. I have this wedding ring on my finger at all times. So I have sensory neurons for my sense of touch that would tell me that I've got this piece of jewelry on my finger, but it's not changing. So my sensory neurons for touch don't need to keep saying, pew, 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 you're wearing a ring. Pew, 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 you're wearing a ring. Just like if you're wearing a Band-Aid, just like if you go into a room with a smell, or if you get into a cold pool. Don't you almost always say when you go into a cold pool, oh, it's not that bad once you get used to it? It means your senses, whatever sense we're talking about, gets used to it and stops going pew, 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 because our brain already knows. And by not having to go pew, pew, pew to all of these sensations, it frees up our attention and our sensory neurons to react to changes and to make sure our minds are constantly aware of our environment. But it doesn't need, considering I've been wearing this pretty much all day, every day for 7 or 8 years, whatever it's been, I don't need to constantly be aware of the fact that I'm wearing a ring. My brain knows that's enough. And then this final concept is pretty fascinating. It's called synesthesia. And I will show you this video that you see to the side. I'm not going to show it, I'm not going to show a YouTube video within my YouTube video. But it's the idea that one sensation system is sometimes experienced through another. For example, for me, it's also coffee, but I give the example of smelling mint may give you the sensation of taste. Just by smelling mint, you might feel like you taste it on your tongue. Or for me, if I have a headache because I haven't had my morning coffee, sometimes just smelling it will make me feel better. Another common example might be if you if you hear the fire alarm go off at school or in your house. You might feel like you're experiencing a sense of hot, even if it's just a fire drill and there's no fire at all. Just the sound of that alarm, that sensation of that alarm might trick your body into experiencing a different sense altogether. All right, short but sweet one. We will get much more in depth on all of our sense organs in the next few lectures.